Section 1-2, Chemistry, Far and Wide. Here's the objectives. Identify some areas of research affected by chemistry. Describe some examples of research in chemistry and distinguish between macroscopic and microscopic views. Remember, once again, these are the things that they're going to ask you on the test. So these are the ideas, the things that I really want you to make sure you understand when you're done with each section. All right, let's talk about materials. First of all, chemists design materials to fit specific needs. So, if we need something that's going to have a certain amount of strength, or we want something that's going to have certain flexibility or be able to be shaped and things like that, that's what we're talking about. A good example of something that would, we may not think of it as being a chemistry thing, but hook and loop tape, which, for those of you who don't know what hook and loop tape is, we're talking about Velcro. Okay, the idea of Velcro was the guy got the idea from burrs that get stuck on your clothing, and said, I wonder if I could make something like that would do that and then be useful. And obviously, if we think about it, Velcro is pretty useful stuff. We have it quite often. If we're talking about something that's macroscopic, we're talking about things that are big enough for you to see with the naked eye. So, the picture to the right, while you can see that, you couldn't see it in that much detail, that would be macroscopic. So when you look at the Velcro, it's macroscopic. If you needed to look at something with a microscope, so like this picture here is under a microscope, we would be considering that microscopic. Now, typically I think of microscopic as something that you couldn't see without a microscope, so I probably wouldn't call the hook and loop tape microscopic. But microscopic would be something that, like the size of cells and things like that, things in the atomic level, would be things we consider to be microscopic. Nowadays, many computer parts and things are so small that you can't see them with the naked eye anymore. They're microscopic. Energy, if we want to talk about energy, the chemists get involved in this in quite a few ways. Think about, how many things that we do every day that involve energy. And we might find ways to conserve energy or produce energy or store energy. Think about a battery, That's an example of energy stored that is chemistry. And somebody had to come up with that idea to do that. Or here's another example, Sea-Gel. I don't know if you're familiar with this, but this cute little, looks like kind of a bar of soap on the top here, is an example of something called Sea-Gel. It's a very good insulator, but it's very, very light. And this picture is trying to show you that it is so light that it can sit on some bubbles and not break the bubbles. It's that light. Extremely good insulator and extremely lightweight. So think about it. It might be something good when they're going out into space. You might want something like that, very lightweight. Now, at this point, you probably wouldn't want a cooler like that because it's pretty expensive stuff. But it would be really light to do. Or think about biodiesel. That's kind of a pretty common, thing that we hear about, and obviously has some ramifications for us in Iowa, because a lot of this is created from soybeans, soy biodiesel, so on. So that's another example of something that we're talking about. Batteries we talked about already. Okay. In the medicine and biotechnology field, chemistry supplies medicines, supplies materials, technology, that doctors are going to use. I've been in the hospital just recently with my mother who's in there, and it's just amazing, all the equipment, all of the things that are in there, all the technology that's going on in there, and somebody had to come up with that. That's the idea of what a chemist would do. Biotechnology, we're talking about that, it applies to science, that production of biological processes, products. So we're talking about, how do things work in your body and so on. So for instance, in a biotechnology idea, might come up with the idea of creating insulin. It used to be many years ago for somebody who's diabetic insulin was very, very expensive, and it's still not cheap, but very, very expensive because they had to get insulin from, I believe they got it from like pigs, animals, so they had to create that, or they had to get that from animals themselves, and that was a lot of work to get enough insulin um, from the different animals. Nowadays, that insulin has been created genetically, I guess. From what I understand, is they've taken a gene, a part of that a gene, and put it into like bacteria that then creates insulin as a byproduct, and that's how they do it. Now, to do that originally was very, very expensive, but once they've got it done, it's become a lot cheaper. Agriculture, we talked about this already a little bit, but think about how much more crops we get per acre than we used to. And the reason is, one, we can control the pests a lot more. We have herbicides, pesticides, those types of things. Um, we have better fertilizer. We're able to plant crops a lot closer together than we ever used to because we can give it enough fertilizer and water and all the necessary things that it needs nowadays compared to where it was, you know, 50 years ago. So we have much increase in productivity. You know, they also talk about it here about the jellyfish gene, which is kind of interesting, but they take this gene that makes jellyfish glow, and they inject it into potatoes. And so what happens is they have these certain potatoes, not all of them, but certain ones in the field, and they glow when the soil moisture gets really low. Therefore, you know that it needs to be watered, so they probably have irrigation set up for those. Crop protection, we kind of talked about that already, herbicides, pesticides, all those kind of things. Other things scientists or chemists do is in the environment. They might help to identify pollutants, prevent pollution, come up with ways to, you know, get the toxins out of the air. Or think about, how we used to have lead in all kinds of things. Paint, and there was a lot of lead poisoning. We used to have lead in our gasoline. All that stuff has been removed because we found out that lead is toxic and not very good. And it was really bad for kids in a house that had lead paint chips, and the kids might eat those paint chips and they get lead poisoning. And nowadays, we do a pretty good job of keeping lead out of our environment. Sometimes, you hear on the news how when they import stuff from other countries, China or someplace like that, it might have a very high level of lead, but we keep pretty good track of it, at least in the United States. Or how about throughout the universe? How do we know things from the sun? How do we know what's in the sun? How do we know what the stars are made of? Other planets? This is all part of chemistry. Starting in the 1800s, they started to discover what was in the stars, and they did that by analyzing the light that came from a star. From that information, you could tell, hey, a star is made up of mostly hydrogen and some helium and then some other things. And as you get older stars, not like ours is a pretty new star, but as you see older stars, it gets to be a lot of heavier metals like iron and zinc and those kind of things that aren't around in new stars. And they can tell all that just by analyzing light and doing those types of things. So that was something that was started back in the 1800s. And, helium was really first discovered on the sun, not on the earth. They said, hey, there's a gas. I figured out that there's a gas on the sun that didn't exist, that we couldn't find anyway, on the earth, and that was helium. All right, so think about these questions. When chemists develop new materials, what is their general goal? Name 3 ways chemists help meet the demand for energy. How do chemists help doctors treat patients? What role do chemists play in agriculture? How do chemists help protect the environment? And describe 2 ways that chemists study the universe. might want to jot those things down just to make sure that you know. All right, here's your next assignment. Log into your Moodle account. Hopefully you've already gone on there, you know how to do that. And post your comments to the question in discussion forum for section 1.1. Now, you need to post at least 2 different days. So, you know, you might get on there today and post your thoughts about this question that I've posed, and then come back tomorrow or the next day and then comment on somebody else's. Now, hopefully, you know, you don't just say, oh, this is just an assignment, I'm going to do my 2 and be done. I'd like you to read them, and, you know, if you have things to comment about, then do that. When you need to get at least 2 posts that have, you know, a paragraph, and paragraph being 5 sentences in each one. You know, when you post just saying, "Hey, I agree," or "No, I can't. I don't agree with that," that's not a good enough post for you to do. So, you know, I want a little bit more than just those kind of simple things.